Welcome, everybody. We're very excited here today to listen to Mr. Barnes tell us about optimizing performance with variable speed pumps. We're just going to wait for a few more seconds to gather in the last few attendees who are still joining, and we will get rolling in about 10 seconds. I'm seeing those numbers go up. And I think we have a quorum, so let's get started. Steve Barnes, welcome, Director of Science and Compliance for AquaStar and industry veteran of almost all things technical in this industry. And just glad to have you today and very interested to hear what you've got to say.
Thank you, Scott. I appreciate that. So my name is Steve Barnes. I am the Director of Science and Compliance for AquaStar Pool Products. And I've been in the pool industry since March 1st, 1984, so almost 40 years. And that's relevant, I think, to this discussion because I started out as a research and development lab technician, still involved in that world heavily. But one of the things for an in-floor cleaning system company is throughout the 80s and early 90s, a big part of my job was to test all of the pool equipment and primarily the pumps. And there was about 13 manufacturers at the time with everything from half horse to 3 horsepower and everything in between. So I really have spent a huge amount of time dealing with a lot of different pump technologies. And then later in the 2000s, I was heavily involved again at the in-floor cleaning system and was getting prototypes from the manufacturer that kind of brought in variable speed pumps and introduced this concept relative to a drive on a variable speed pump in any event, and dealing with the massive headaches that variable speed can give you when you are only accustomed to single speed pumps. And so it was a big deal for the in-floor cleaning systems. Subsequently, I was involved later in 2013 and 14 with commercial pools with variable speed pumps because they were starting to hit that market. Historically, public pools said you had to be single speed, you can't touch anything. And so that was a big project in the city of San Antonio. City of San Antonio, Texas owns 26 pools. They own them, they operate them, everything about them. And so there was a very deep dive on all 26 of those pools. 24 of them ended up getting variable frequency drives and moving to variable speed. The following year, after all of that equipment was installed, there was all kinds of water quality monitoring 3, 4, 5 times a day all over the pool just to make sure all of this stuff was working. And through those lessons, that is kind of the foundation I want to bring to this presentation and a perspective, because this applying variable speed technology effectively and without headaches and problems is not easy. And so hopefully the takeaway from this webinar will be certainly some insights on what to do, not to do, and how to optimize. But I'm going to go through this quick because to really delve into this on any one of these subjects could take hours, certainly a 2 or 3 hour training class kind of a thing. So I think what you will come away with, and certainly what I hope for, is this: you'll know what you need to know to add what you already know. But I think there's going to be some interesting stuff here, and certainly I'm going to try and highlight the gotchas, and the whole goal here is to help pool professionals become really professional. So with that said, let's get into really what are our customers' expectations. At the highest level, they want just a very enjoyable outdoor environment where water, hopefully moving water, is the centerpiece of their lifestyle, what they're doing. That's what we are all about in this industry. So ultimately, the goal of this presentation This is what we're trying to meet. Now, obviously, it's very much dependent on the property we're dealing with and the water features. If it's a 1980s flat water pool, the opportunities for something like we see here is certainly not very big. But then there's everything to massive water parks with lazy rivers in the backyard. And my goal is to try and make sure all of these aspects of this presentation can apply to all the different places we use swimming pool pumps. But ultimately, the goal is to try and help us as pool pros deliver the optimum environment in the backyard. So let's start by talking about, well, who qualifies as a pool professional? I mean, professional sports, right, is the definition is not necessarily of the talent, although certainly they probably wouldn't be getting paid if they didn't have extraordinary talent. But in terms of professionalism, if you get paid, you're a pool pro. And I guess if you're a pro, if you get paid and happen to be working on pool stuff. So that bar, I think, for purposes of what we're doing, is probably not quite high enough not to achieve what can be achieved with variable speed technology. So let's look at something again from the customer's expectations and their perspective is when we compare ourselves in the pool industry to something like air conditioning or other trades. One, there's a very high likelihood that when you need an HVAC system serviced, that they're going to show up in a very professional looking truck, vehicle, or van. They're going to be wearing uniforms. Certainly the average top, and even certainly the top tier, but even the average HVAC technician is going to be perceived as very professional by the property owner. Often, and in most cases, they have to be certified. And so part of that certification is involving what the tools that an HVAC system involves. So they have absolutely proper tools that are very unique to what they're doing to service AC units. If they replace an AC unit because of that licensing and certification, they are going to select the unit that is right for the application. Square footage, the environment, whether you're dealing with Arizona, where I'm from, where we literally have 2 or 3 or 5 days a year now that are into the 120s, and our average from June to late September, average daily temperatures between 105 and 110. Those are very different air conditioning units than what might be used, say, where AquaStar is at in Ventura, which they hardly even run air AC here. And then you go into cold environments where now we're dealing with the heat is a dominant part of the year. So in the HVAC world, they are very much focused on what is the need of the project, not necessarily the brand or the model that's on sale that gives them points to go, to exotic places. That's just not the culture in the HVAC systems. And so, but that is how we as pool professionals, that's what we're gauged against for an average pool owner that comes back from a 2-week vacation to find this. And so they are putting out a call for help. This is often the triggering point that we go from a single speed pump to a variable speed pump when that existing single speed pump dies. Now, there's lots of opportunities, certainly when single speed pumps are on the way out, because we know you've replaced the bearings multiple times, or the seals, or it's noisy, the performance is going down. So we do often proactively, hopefully, proactively replace single speed pumps before they fail, because then there's some advantages relative to if you document what the single speed system is doing, especially if it's working, then you have a sense of what does this pool need In this case, it would kind of be just a simple circulation, but obviously we have pool spa combos where we have jet considerations. You go to the top tier relative to performance needs of vanishing edge pools, especially with Lochner edges that go all the way around it. There we get into really big pumps. So all of those things are where we as pool professionals, first and foremost, have to understand what is this pump going to be doing so that we can size it properly and it's the right equipment for the application. The advantage of variable speed pumps is their variable speed. So you can, and it's probably most common and generally makes a lot of sense to go with a larger horsepower variable speed pump, especially if there's no big cost difference between a 3-horse and say a horse and a half or something like that, because you get some more flexibility. But you are also bringing on potential headaches that we will cover in detail in the back half of this webinar. So as we look at dealing with the customer needs, if you get to the pump beforehand, you can understand, especially if it's a new property, if you're a service pro who's out there weekly, you probably know your pools. Each one's kind of got its own personality and quirks. So you got a massive head start versus this homeowner says, hey, my pump's not working. They maintain this pool themselves. So they start going into Yelp or somewhere online and searching for pool pump repair. Well, they may come across, general purpose, what we used to call handyman kinds of services, some of them very professional. So we look here as a Acme, fictitious company, obviously, service and repair, and they replace appliances, pool pumps, they even do toilets, and they do like for like replacements, okay? This company shows up in a uniform, they're very professional equipment, professional looking van. They diagnose the pump, say, oh, it's a pool pump, I need to replace it with something else. And they are very effective at doing that. In other words, they know how to do rudimentary plumbing so they can take it out and even adjust the piping if necessary for the new pump. Certainly they're capable of connecting it like for like. And they are perceived by many homeowners as being pool, as professionals. And why wouldn't they be? And then you have the conveniences, they're available 24 hours. And generally speaking, those of us in the pool industry would prefer to have a life between 11 and 6 a.m. And so there's that element of competition that's out there. And this is where we're seeing a lot of the problems where it's just take out an old pump and put in a variable speed, and then they run it on full speed. And so there's, a lot of missed opportunities with that. And in effect, by doing that, we are absolutely wasting this homeowner's fund money. And potentially, if they just hire somebody who says, yeah, I can do that, a handyman or a home warranty kind of company that handles this kind of stuff. This home warranty, this professional appliance replacement kind of thing is in the forefront because we had an air conditioner go out and then we had other stuff go out. And so these were the kind of people on the HVAC that we were dealing with. And that's literally where I saw, wow, they do pool pumps now too. So this is interesting. But the bottom line is if we are only looking at replacing a single speed pump with a variable speed pump, and typically that variable speed pump is going to have a lot more power, even a horse and a half variable speed pump, because of the dedicated purpose pool pump law that has minimum what we call WEF, and the details of that are kind of as meaningful to how we drive our cars as the miles per gallon on the stickers when we buy our new vehicles. And so that detail really doesn't matter, and I'm not even going to cover it in this. But the bottom line is to meet those minimum energy efficiency requirements, the wet end has to be more efficient. And that's why you've seen some of the wet ends that were associated with single speed pumps have gone by the wayside, and they've come out with other pumps that are equal in size, but they have a higher performance. And so it's very rare in my experience that you're going to replace a single speed pump with a variable speed pump and not see a pretty significant performance boost capability. And if the old system is not capable of that, then we have some problems, and we potentially has some safety hazards, some performance hazards, some flooding hazards, and that's what I'm going to get into, and hopefully make you aware of the kinds of horror stories that we hear as educators and being involved in codes and standards and all that. I didn't give you my background on that, but those have been around for a while now. I'm heavily involved in the PHTA and drain cover standards and energy efficiency standards and stuff like that. In that role, we hear of the problem. And so this illustration here is the single speed pools are so much easier that they were and also generally speaking, the pump and the equipment and all that was sized so that that single speed pump would be operating something near the best efficiency curve or the middle of the curve. Certainly that's what our hydraulics courses, that's what proper engineering teaches relative to single speed pumps. And when you go to a more powerful variable speed pump, we end up losing water quality. And it's very counterintuitive, and there's a couple of ways that happens, and I'll get into it in the next few slides. But one of the most common ways is you put a 3 horsepower pump on 1.5 inch, in some cases even 2-inch pipe with long runs or lots of elbows, and now that pump is cavitating full time. Cavitation crushes the pump's performance while still wasting energy, and it's self-destructing. The cavitation's at a minimum going to take out the bearings early, or excuse me, the seals. But you know, we run a 3 horsepower variable speed pump in the AquaStar lab all the time, and we take it to cavitation when we're finding limits. You're going to see video of that, and we've had to replace that impeller and diffuser because we've abused it in a lab environment for quite a few years now. And so it's something we have to pay attention to monitor the performance of the pump for ISO 17025 testing and some stuff like that. It's another area where we're really focused on the nitty-gritty detail of the performance of all of this stuff. So it's counterintuitive that you could put a bigger horsepower pump on a pool and end up with not being able to keep the pool operating properly. And that's one example, and I'll show you some others. So kind of with that foundation, let's focus on some of the things that Acme appliance replacement service probably doesn't know anything about, and why it's so important for us, the pool pros, to hopefully be doing this work for these homeowners. So new technology challenges, okay? Excessive pressure and flow. So because of that new, bigger, more powerful pump, often, incredibly often, that new pump is going to exceed the limits of the filter, what those filters are designed for. And that can cause a new safety hazard, especially on old pumps, now on old filters. Now this one, I intentionally use this because it's not available on the market, so I'm not picking on any one manufacturer. The other element of this filter is it is stainless steel, so the powerful pumps are not causing pressure related failures that we are seeing with old polymer, fiberglass, plastic filter tanks that you put a new variable speed pump on, and then you get a call 3 or 4 or 5 or 6 weeks later, maybe a few months later, that all of a sudden it's sprung a leak or worse. So when installing variable speed pumps, you have to look at what will that pump be capable of on the pressure side and potentially on the flow. But I'm going to pause on that one because we're going to go into a lot of detail back pressure and the effects of flow on various variable speed pumps. So, but the pressure side of this is something to be extremely aware of, and that might be if it's got older plastic tanks. This would probably want, and you're only, because the homeowner just needs a new pump, all right? This is where you probably want to be more careful and look at what it is you're replacing. What is the equipment pad look like? What is the pipe size? What is this old filter? And make sure you may want to go with, instead of a 3-horse, you may want to select the 1.5 horse or a 1-horse, or even downsize. Well, you can downsize below 1 horsepower and stick with a single speed, but even that's going to go away, I think, in 2 years, because they have now passed, the Department of Energy has passed the dedicated purpose pool pump motor rule, and it will outlaw single speed pumps all the way down to 1/2 horse. And so that's going to have some ramifications on even on public pools, peristaltic pumps, chlorine booster pumps, venturi bypass, again for acid draw and other things, but certainly our robotic cleaners, booster pumps, all of those are going to be going to variable speed because the motors are only going to be available in variable speed.
Holy
So
cow.
that's,
I didn't know
yeah,
that was, that's the first I've heard of that part.
yeah, I only learned about this I knew it was in the works. It's been in the works since 2014. But I just learned like last week, 2 weeks ago, that it is actually passed. And I believe the deadline when manufacturers can no longer make single speed motors, I think is September 29th, 2026. Could be wrong on that. We can figure that out. That's a seminar for another day.
Yeah.
But heads up, this variable speed technology challenge is going to spread into other product categories, not just the filter pump or dedicated purpose pool pump. So heads up on that. Now's the time to really figure this stuff out before it gets even more interesting in a couple of years. So another element, did you want to talk about that anymore, Scott?
No, I'm just making notes about future webinars that when we start to change motors and all these different applications. So I'm just
Yeah,
making.
they're plugging the new motor, so it's just a general purpose motor that bolts onto pool pumps. So they're plugging that loophole, and then also my understanding is the rebuilding and rewinding of pumps to just motors to replace them. They're trying to address that loophole too, or I'm not sure. That one gets a little bit more unique because that's a state by state thing. So in California, look out. In other places, maybe not. But anyway, a lot of detail there. So now so excessive pressure, first and foremost, watch out for these old filters and make sure they can handle this new powerful pump. And then, so one of the other elements of it, when you look at the performance of these pumps relative to the grid or the filter media, be it cartridge, the DE, or even sand, where the housing may be fine and there's no risk there. But if you exceed the flow rate of the filter media, there's a couple of things that do happen, and the pressure and flow is so high that it actually tears or blows through the filter media itself. In the case of sand filters, I've heard it called wormholes. I know there's a better term and I just didn't have time to look up the proper one, so forgive me on that. But if you exceed the flow rate of sand filters, it basically will tunnel and you end up radically reducing the square footage of a sand filter. And so what happens in these scenarios, if you're just overpowering the media with flow and pressure, all of a sudden the small fines go through the filter media and you end up with cloudy water. and yet your chemistry is spot on. You do the LSI index, you go through all of that, and what changed is a more powerful pump. And so that's one of the gotchas that we've seen in doing the variable speed replacements in San Antonio. We had 3 different pools where the filters, I got to be careful because I've used the city name, but there was 2 filters that were never sized right in the first place. There should have been 2 and they only installed 1. And what was happening is these new variable speed pumps that were actually achieving, because we installed brand new flow meters on everything that actually controlled the drives. So they were hitting flow rates that these pools had never seen historically. And a couple of sand filters, it was blowing through their media, and it was 3-4 months, 3 months in the summertime of these pools constantly getting cloudy, so they were draining and refilling. That's a problem. One of them was 250,000 gallons, so that was a serious problem. And it turned out that the pump was actually moving more water than the filter system was capable of handling, and so the solution was to replace the filters or add a second one in one of the cases. So cloudy water can be caused by overpowering your filters. So then the next thing, another tell is where the water quality is maybe not going out because there's not a bather load that'll generally drive cloudy water, or pets or other things that the environmental concerns, but you will start seeing debris below wall returns, sand, heavier twigs kind of thing. And that's an indication when you see this, or maybe DE, that you have a torn media. And again, these are tough these 2 issues are tough to troubleshoot if you just don't know about such oddball things. It's rare, but then again, rare pools cost us a fortune, right? Having to go out and unhappy customers and all of that. So that's number 1, watch out for new technology.
You'd get
Another,
I'm sorry, Steve, you get that debris because you're still dealing with an overpowered media, and it's actually blowing all the way through a channeled sand filter, or where's that debris coming from?
So relative to the cloudy water, I've only experienced that with blowing through sand filters, public pools, and some residential stuff when we were putting giant 3 horsepower pumps back in the day on sand filters. So we saw that there. But the new debris under the floor returns, that's going to be a tear in a cartridge filter or some other pressure related problem with the cartridge filter. There's multiple ways they can not like that. And then also very common, it's a common way to spot that you have your DE grids are starting to fail. I love DE forever. I love the clear water associated with DE. So that's what my parents' pool and family's pools. And this was how we knew that we were losing a grid, is the debris below the returns.
Right, going right through there. Okay.
So now we're going to move into one that's really important from us, which is excessive suction. And this can take us in 2 directions. One's super dangerous and the other is just expensive. And we're going to start with that one. And that's when the new pump exceeds the pump suction limits. So we have a 3 horsepower pump that is replacing maybe an older, much older single speed 1 horse or horse and a half. And now we put a 3 horsepower pump on it, and the pump's running at full speed, and the suction exceeds what that pump can handle. And this is where there's been a long standing, certainly I shared this for probably 35 years, misunderstanding that pumps suck. Pumps don't suck. Well, some do, but that's a different story. Pumps don't suck. Atmosphere pushes. Okay, so we actually, swimming pools and swimming pool pumps are really 2 pump systems. Gravity pushes water through the pipe to the pump. The pump pushes water out of the impeller diffuser back to the pool. So it's important to understand that water, the physics of water, is it is a particle. To understand what moves water, think in terms of sand. You can't grab a handful of sand or a handful of water and walk away from the bucket or the pool like it's a rope. Okay, you can't pull water, right? The only way you can move water is to push it. So what happens is the impeller, centrifugal force, flings the water sand particles, right, and boosts it into pressure, and then the atmospheric pressure pushes the water from the pool to the pump. And if you get the pump too high, in case you doubt the physics of this, just go install a pump at 35 feet and see how well it works. It will never work because atmospheric pressure, even at a full vacuum, which a pump's not capable of, is only 33 feet. So if that pump's at 35, it will never, anywhere on this planet, ever get water because we only have atmospheric pressure. And the higher the elevation, we used to see lots of problems with in-floor cleaning systems in Denver because of cavitation on the pumps. And at the time, I had no clue what the problem was, but so we've been dealing with that for a long time. So, and the higher the power of the pump, the more water it'll move, and it can move more water out of the suction pipe than atmospheric pressure can push into it. We call this cavitation. We see it in the form of high vacuum gauge limits. Temperature makes a difference, elevation above sea level makes a difference, and on the technical side, you get into big commercial pumps and applications. This concept is called net positive suction head, and that means you have to say positive, atmospheric pressure has to be positive enough to keep up with the speed of the water leaving the pump. So, and when we don't do that, then we have cavitation or worse. And so that can be caused by small pipe, that can be caused by the correct size pipe, but the pump's 500 feet away because it's $1 million pool, or somebody gets free pipe. Elevation makes a big difference. So this one gets really complicated, and going back to the HVAC system, technicians, when they come in to troubleshoot an HVAC system, they measure stuff like voltage and all kinds of stuff, but they also measure the pressure on the refrigerant and all kinds of things, because there's no way to know by sound, sight, looking at it. So sometimes you just have to measure, and we're going to cover that process in a fair amount of detail coming up here in just a few slides. So that's number one. And the obvious thing is it causes pump noise. And what that noise is cavitation. It may be cavitation in the pipe, and obviously we hear it at the pump, but if you get down and listen close with a big pump on small pipe, old Ortega valves, I'll use the brand because they're not around anymore, you know, little itty bitty old-fashioned valves, you'll hear them squealing because they can't handle the flow rate of these new pumps. And then certainly if you have a big modern pump and then reduce it down to 2-inch or 1.5 inch when it was, its performance curve is based on 2.5, maybe 3-inch pipe on some of the bigger variable speed pumps that are in the residential market now. So be aware, the first clue is going to be pump noise, even after the pump's primed. And we're going to cover priming a little bit because that's kind of a gotcha sometimes also. So here is a video of cavitation. So what cavitation is, it's the pressure gets so low inside the pump or in and around the pump impeller, which you can see one that's been just destroyed by cavitation up above. But literally, the water pressure gets so low, it vaporizes water. So keep in mind, what is water? Water is H2O molecules that are individuals. And if the pressure gets so low, then they start to separate from each other. The space in between them we call water vapor, and I'll run this again. And so this is the physics that's happening inside the pipe. Now, in this case, this was done in the AquaStar lab, and this is a 22 inches of 1.5 inch pipe, and then it goes to 6 and ultimately 10 inches of pipe. It's the only reason this demo was possible is because that pump that I mentioned that I messed up with cavitation. Yeah, this was, we think, when it happened. What we do is, because it was 10-inch pipe 20 feet away, it was able to keep up for, I don't know, this ran for a minute or so before it got to the pump and caused a problem. So again, I'll show this one more time. This is extremely noisy. You can't hear it, but this is what cavitation is, and it's vaporizing the water. So let's look at, so the excessive, so that's cavitation. Now let's look at another safety issue, and this can be an existing problem that you are inheriting by replacing the pump, or you're creating a new one because now you have a higher performing pump on a suction system and piping system that can handle it. So now you get to a much higher flow rate than the original designer contemplated. So we're exceeding the VGBA limits. So that would be a new suction hazard. And in the pump manuals, because they're required to say this, and under the VGB Act, even for residential pools, as a pool professional, or even that Acme replacement, because he's supposed to be following the pump instructions, it says when you change the flow rate of the system, you got to look at the drains to make sure they're safe and okay. If you don't, and something happens in the future and you install the pump, I'm pretty certain that you're going to be a part of this very unpleasant party that I've been a part of more than once. So pay attention to the drain covers, keeping in mind that these hazards are normally invisible and potentially deadly when you put a variable speed pump, and this is what you find in the pool. These flat and flush mount drains that have been illegal since 2007, but have continued to be sold on that big smiley company that sells anything and everything and will deliver on a Sunday night. And they've had to pull down flat and flush mount drains like this just this year. There was a recall on this style that was being sold through that online retailer. So please be careful and be aware. This drain specifically is the style that Virginia Graham Baker was held down on, that residential spa. So believe me, if you have a pool that has any kind of safety incident that involves lawyers, expert witnesses, and they see this, boy, it's going to be tough for any lawyer to help you. So please pay attention to these. Now, on this, I will make a point because it actually fits in where we're going. One of the legitimate options is to disable the drains. And so you can do that by just turning off the valve, maybe locking it on 100% skimmer, and that in and of itself gets into other issues. So I'll just say it is an absolute option. If you're not sure and the system works, that's something to consider. There's also when it could be a fully compliant VGB drains and systems that you still want to reduce, if not turn off, the drains so that you can maintain skimming action. And we'll talk about that a little bit in the next section. So one more gotcha that actually happened to me on a pump install is the full speed priming. And it was when we had, for the pool, it was fine. Obviously, this is just a hypothetical, but when we had it on a boulder waterfall kind of a thing, and then turned off the pump and it came back on in priming mode, man, we sent water everywhere. And so then we had to come back in, and it didn't need a priming mode for this pool other than initial startup. And so I think it defaulted to 5 minutes or something like that. So we had to scale it way back, and Ideally, don't start the pool in 100% waterfall mode, but sometimes homeowners do such things. So be aware of the priming speed and the priming time as a pool pro. If you need it, you need it, but if you don't, this is something where you can either slow down the priming speed or reduce the priming time to optimize it so you're not tearing up the pump and making a bunch of noise during a priming cycle that the application doesn't call for. And so again, in this, it exceeded the limits of a particular waterfall. So with that, so now we're going to talk about, I want to move into the professional, some of the programming techniques and all of that, what it takes to be a professional, and separate us from we want to be perceived like the air conditioning guys and not just like the appliance replacement guys. And I'm going to go through this quickly because there's no way to teach it effectively in this kind of seminar. So we're into this section. These are things you need to know as a pool professional to really achieve the goal of maintaining amazing pools with water features and all of that. So let's start with, you need to understand what total dynamic head is. That's what's on the left side of swimming pool performance curves. And it's what is used to size pipes based on hydraulic calculations and stuff on new pool design. So basically, the higher the head or the higher the pressure, which could be higher the filter pressure, the higher the vacuum pressure, those all drive higher TDH. And so high TDH, low flow. If you got low TDH, you have high flow. And this is a 3 horsepower pump curve. And so every pool, every water feature is a snowflake. And so how do we find out what this actual pump is performing without a flow meter installed? So this is the process. You measure the pump vacuum. There's your conversion factor, 1.13, gives you 1 foot of water. Measure the pump pressure. 1 psi equals 2.31 feet of water. And the whole point here is to get into TDH, which is feet of water, because those units, inches of mercury doesn't go above atmospheric pressure, PSI doesn't go below, so those units don't work, so we have to do this conversion. We convert to feet of water, and then we add them together. This is a lot more complicated if you have multiple layers of elevations of water or your pumps below water. So this is a concept, not an absolute. And so the way this works is we convert 10 inches and 10 inches to feet of water. We convert PSI to feet of water. And in this example, we have 57, and this is from a real world, so that's why I started with it. The way you read it is you look up 57 on the TDH side of the chart, scroll down, move down, and you can look up the TDH. This is extremely accurate and accepted by health departments to validate public pools when they don't trust flow meters or just want to validate what the pump is actually doing. So this is a very accurate way of finding out what your pool is doing. And once you know this number, we can do a lot of things with it. So let's start by, this is a pump curve, and we look up that 57 TDH on the left, and then we're going to go down and find out that it's 116. So that's how this tool is used. Now, another tool in your toolbox is going to be the pump affinity law. And this is a law of physics that you can absolutely trust. And again, I'm not going to try and teach this, but there's formulas and even TDH calculators by some manufacturers and things where you can use this. But basically, it says the one that's going to matter is if we reduce the RPM by half, the flow is going to reduce by half. So on the pump affinity law, speed and flow are proportional. So it's a 1-to-1 relationship. So you can just do the math and find out what your flow rate. Now, the other thing to keep in mind is that pressure is proportionate to speed squared. So the pressure is going to, the speed is going to reduce by half, but the pressure that you see on a filter gauge, for example, is going to reduce by 75%. That's another number that you can calculate. And then the energy savings comes in as that reduces by a factor of 3 cubed. So half speed, 1/8 the power. So let me say it one more time. Half speed, half flow, half speed, 1/4 pressure, half speed, 1/8 the power. That's why we have variable speed pumps, because of this affinity law. And there's a lot of information on this online. So now if we take this exact same process, but now we're dealing with, the first one was a 2-inch system, this one's 1.5 inches, and you can see now with the same pump, our TDH has gone way up. Our vacuum level has gone up from 10 to 20. This will be in cavitation or very close to it. Obviously, small pipe, our pressure tends to go up also. The same process here, but when we do this calculation, we went from 50 to 80 TDH. Okay, so, and most of this is on the suction side. So in the cavitation. So this pump will run here for a while, but not a lifetime. And so same process. We find it on the curve. Okay, this is our new flow rate. Now we apply the affinity law. And if we look at half speed, it's down here at 21 gallons a minute. And the TDH dropped from 80 to 20. So you see this relationship, okay? So this is the case where you put a big pump on small pipe and it's into cavitation and basically on a mode to self-destruct. So that's a problem where we have to either slow down that pump so it doesn't cavitate, which is a good solution, but it takes some know-how. Final step here is we look at the other extreme, and this is when we have 4-inch suction, 4-inch return. Again, we have a lab that we can basically do whatever we want with pipe size. So important thing to understand is this pump is absolutely at water level, not even 18 inches above, and no filter. So the inches of mercury just, you can't even read it. The gauge sits at 0, basically. We actually use differential gauges. And then the back pressure was something like 4. Again, it's in the noise of the gauge. But we look at that and it's close enough. We see this is 9 TDH. Now let's look at this on the pump curve. So we go to 9 TDH. It's way out at the limits of this pump, which is why I have the data. And you can see it's up here at 187 gallons a minute, same pump. The reason I wanted to show this is if you have AHJs or code officials saying you have to use the max flow of the pump to confirm VGBA compliance, this is just, you can't get there. It causes all kinds of problems. That's multiple seminars in and of themselves. But measuring TDH, it's why I mentioned the health departments. If you actually measure what you have and document that, then they will accept the actual flow rate instead of this theoretical flow rate, especially for drain cover and VGBA compliance. So again, same physics apply. The pump affinity rule creates this system curve. Same rules apply, half speed, half the flow rate, half the TDH. So you can see this works across all variable speed pump. It's just a physics of variable speed. So you can use this as a tool for any pool. So now I wanted to last bit of applying this concept in, so you can see how this can be valuable to show a return on investment and your time to program and learn and educate yourself with this to separate yourself. So if we look at the single speed pump, this is that same pump, the 3 horsepower pump, but on a public pool running full speed. Okay, so it's going to operate at 24 hours a day and it's 2,300 watts. Okay, and so if we look at that, this happens to be California, San Diego rate of 38 cents. So that would be 55 kilowatt hours, $22 a day, or nearly $700 a month. So homeowners would pitch a fit and do. So we don't do this, right? So what do? We install a variable speed pump, run it on high speed for 1 turnover for 8 hours a day. Okay, so we reduced the cost by a third, same rate. Our kilowatt hours have dropped by 2/3, and that means our energy bill has dropped by 2/3 also. So instead of $22 a day, we're looking at $212 a month. And okay, for California, this is an unfortunate reality. So let's stick with this. And now this is the part I really want you to pay attention to, is if you take this same $212, $213, and just program the pump, you're going to solve this problem where during the 16 hours the pump is off, the debris settles in the middle of the pool, right where the homeowner's looking at it. So these pools are perpetually dirty in appearance, because not only is the stuff going to settle that landed on the pool, but everything that lands on the pool in these 16 hours tends to sink. Even leaves are going to sink after 20 or 30 minutes. So now they're on the bottom of the pool, and it's just a real pain to work with. Versus if we keep the skimmer working, which is why I mentioned earlier of turning down or turning off the drains, so that you can run the variable speed pump at a lower speed, a speed that the skimmer will work. That sets your bottom. It may be a salt chlorinator. If it's a heater, there might be other reasons that you come off of this half speed. And there's also reasons you can go below this. But here, this is the affinity law. This is half speed. So we're running 2 hours on high, then we're on low speed for a while, then 2 high. So you can see visually how we're alternating. Now, what I want you to look at is we got our high and our low watts. So on low speed, we're down at 300 watts. High speed obviously stayed the same. So if we look at this, our San Diego rate hasn't changed. Our kilowatt hours are approximately the same. We're looking at $7 a day. And in this case, because this is running on high speed and it doesn't need to, but I use the worst case scenario to make this illustration. So for the same amount of money, approximately, of running that variable speed for 8 hours and turning it off for 16, you can run it 24/7 or run it 22 hours, kind of a thing. The other thing is look at your local incentives on when they do and don't want you running on high speed, and adjust this accordingly. In a solar area, they want pumps on high speed during the day and off at night. So it varies by zone, but be aware that think creatively for how you're doing your filtration, so that we don't have water settling and debris settling in the middle of the night. So the bottom line is single speed simplicity is gone forever. And hopefully this has been helpful. And Scott, I run a little behind, but not too bad. Any questions?
No, we're good. I wish we had time for all the questions. We'll get to what we can. And that was just fantastic. There was so many things in there that I had not seen or thought of before. But that's a discussion for another time. First question. I understand why pumps cavitate when TDH is too low, not enough resistance. But I don't understand cavitation when resistance is too high for the pump. Can you simplify an explanation as to why the behavior is the same when TDH is too high?
Okay, so the TDH, remember, it's the suction side added to the pressure side. So if you have small pipe on the discharge side of the pump, or a dirty filter, or they close a valve or something like that, now you have really high TDH and low, oh, hang on, I got an emergency. I'm gonna lose I didn't plug in my computer, my apologies. And it's saying I'm gonna go away. Okay, ooh, that was close. So if you have high back pressure, you will have high TDH. So let's say we have 35 PSI on the pressure side and only 2 on the vacuum side. So there, the high TDH is caused by back pressure, and the atmospheric pressure has no problem keeping up with the pump. Go to the other side, your skimmer basket is plugged up, or your pump basket is plugged up. Now that high TDH is on the suction side, the back pressure doesn't, so the pump's able to send the water out of the pump faster than it can get inside. So basically, small pipe is a contributing factor where it may have been okay with a 1 horsepower pump, but now we do a variable speed with more power, and now you get a new challenge.
Gotcha. This question goes back to when you were talking about drain systems and covers and so forth. The question is, Steve, the evaluation of drain system goes beyond just the cover, correct? The design of the sump and the pipes matter too, right?
Absolutely correct. So in the 2017 standard that changed as we went from 1 flow rating on the floor and 1 flow rating on the wall. And then you didn't matter what the pipe size was. Depth was always a part of this, but it was often overlooked. Under the new, the U.S. Consumer Product Safety Commission proposed that we test every pipe size, orientation, pipe depth, and each one of those results in a different flow rating, largely because if you look at how much water you can get through an 1.5-inch pipe without cavitating versus a 4-inch pipe, that's a big difference. So there's that aspect of it. But more importantly is small pipe, the hair goes inside and plugs it up. So it just blocks the suction outlet. And that's why, even though the pipe maybe can handle it, once we do the hair test, which every drain cover has to pass 20 times, then we see crazy low numbers on those. So it's pipe size, pipe depth, each one of those will get a flow rating.
Gotcha. I think we've got time for 2 more. What authority is responsible for ensuring pool owners get variable speed pumps?
So this one's kind of convenient relative to or not convenient, depending on your perspective, I guess. But basically, it is illegal to manufacture call it a 1 horse to 5 horsepower pump, that range. It's illegal to currently manufacture those unless they are variable speed. There's tests. The law doesn't say it that way, but to pass the test, you need variable speed. Some 2 speeds used to pass. That gets a little more complicated, but all of that's going to change in a couple of years when you can only buy variable speed motors. So the bottom line for anybody in this audience other than the manufacturer or an importer is if you can buy it, you can legally install it. But good luck finding a 2 horsepower pump now. They're
Right.
just not available in the market. The same is supposed to be true on the drain covers. We as manufacturers and importers are not allowed to bring them in, which is why that, people that are importing them that are not compliant have the CPSC give them a little knock on the door and say, hey, we want you to go replace those, and by the way, you have to pay for it.
And in 2026, when they do the motors, they'll probably take the same approach, right? That same approach to it.
Yeah, so the motor manufacturers, it will be illegal for them to manufacture them in the US or to import them into the US. And so that they dry up the supply chain basically, which is actually some of what the pool industry supply chain headaches were because of this variable speed pump rule.
I like the simplicity of that approach. I've got time for 2 more. Steve, the point you make about turnover and circulation being 2 entirely different requirements should be plastered onto banners throughout the industry. I agree with pulling more from skinners than drains because of where debris lives. When calculating for velocity, if there's a valve between the skimmer lines and the drain line at the equipment, should the system be considered a 1-pipe suction system?
So I think the short answer is yes from a VGB or suction safety. What you want to do is to check that system out, you will want, for example, you install a variable speed pump, it's got skimmer main drains, is you would want to look at your flow rate or your TDH with the skimmers off and your pump on the highest speed you've programmed it for. If you have have a lockout that could be something less than full speed. If you're not using the lockout, you have to use full speed. Do your TDH and find out what is its actual flow rate, and the drain system has to be able to handle it, or you need to deal with that, or deal with the smaller pump. Yin and yang, do it two different ways. On the but for hydraulics not cavitating a pump. So now let's say we've got big enough pipe size, 2 inch or something, on both the skimmer and the main drain, and with both operational, the pump is happy. Well, then use it that way. You know, the only reason I would suggest to reduce the flow or turn off the flow to the drains is if you're wanting to improve your skimming action. Because going back to pumps don't suck, atmospheric pressure pushes, circulation, chemistry, water quality is all driven by the return side of what's going on in the pool. We stir it up by pushing water, right? So just like when you
I understood all that. It just came through real slow. It's a neat effect, the underwater effect. It was part of your presentation. Sounds great. That's all the time we have for today. I just want to thank you, Steve. I always learn so much from you, and I want to thank everyone for turning up for this this edifying statement on the state of variable speed pumps. Thanks, Steve, and we'll all get back to work.